Now, today we start a real trigonometry function, section 4.2. Now, same thing. This section we have too many material need to cover, so I may need to separate one section to at least 4 videos. Now, in the beginning, number 1 question: each real number t corresponds to a point xy on the unit circle. What unit circle means? Unit circle means the radius equals to 1. So if you have a unit circle, means the radius is 1. And then depends on what's the angle, you may end up with the end point of the terminal side have a coordinate xy. Now, because the radius is 1, and this means x, here means x, here, from here to here, means y, right? This is y, this is x. Now, by the Pythagorean theorem, x squared plus y squared equal to 1 squared. Or you may say the distance from the origin to the point is x squared plus y squared equals to 1. So if this is the unit circle, then whenever, let me erase those marks first. The unit circle. So we have x and y. Now inside the unit circle, you may use an angle to build. Use angle to build a triangle. Use angle to build a triangle inside the unit circle. So inside this unit circle, we build a triangle according to an angle. Now, for each real number t, why we want to talk about angle and talk about a real number t, and for each real number. So let's take a look. If you have a numerical 9, and we say this is 0. So when angle equals to 0, you cannot build a triangle. Or you want to say your triangle, you have initial side and the terminal side. These two sides merge together, so their angle is 0. If this terminal side and the initial side, they happen to be merged together, so they cannot form a triangle. In this case, the end point is supposed to be 1, 0. And if the initial side and the terminal side open to form a angle T, then you may make a triangle, a right triangle. I suppose to say right triangle. When you make a right triangle, you are going to have xy. So this length is x, this length is y, so the coordinate will be xy. Now, the real number, you may start from 0, right? And then keep going bigger and bigger and bigger up to here. If we talking about degree, is 90 degrees. If we talk about radian, it's pi over 2. So it goes to 90 degrees or it goes to pi over 2. And if the angle even bigger and bigger, you goes to 180 degree, or you say pi, 180 degrees pi. Or you may even go bigger and bigger, become 270 degree is 3 pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2 actually become 0 again. So you can keep going. And you may wrap around the circle one more time. So 2 pi plus 2 pi, 4 pi, 6 pi. So when you go around to wrap the circle again and again, you are going to go through many different angles. Those different angles fill in the whole numerical line. And then if you make the angle go negative direction, you have negative angles. All those negative angles, same thing, can wrap the circle many times. So you have negative a little bit, negative more and more, negative 2 pi, negative 4 pi, and all negative other angles. So all the angles basically are the real number. That's why for each real number may correspond to a coordinate point. This coordinate may build a right triangle, and then you may have xy. So again, let me erase those ugly marks so easier to read. Okay. Now, so this one, first, when we talk about the trigonometry, it's very important. We find a real number and then find the corresponding coordinate. And then we may build a triangle. And the next, we are going to talk about the trigonometry. So number 2, a function is a function f is periodic when there exists a positive real number c such that ft plus c equals to ft. It's too much language here. So let me explain. Basically, they just talk about if you have a triangle built according to angle T. So from the initial side and on the terminal side, you have angle T. How about if you have another angle? Keep going, and come back. We call this coterminal angle, right? So if you have coterminal angle, they end up with the same position, with the same coordinate xy, and you are going to build the same triangle. So basically, periodic is talking about whenever the angle are able to build same triangle. If you use the angle to build triangle and the different angle may build a same triangle, what's the possible situation? If this C is 2 pi, or you say 360 degrees, when you wrap around the circle one time and go back to the same position, you are going to have the same triangle built. So for sure, in the trigonometry, we are talking about the unit circle here. And then when we talk about unit circle, whenever the angle plus 2 pi plus 2 pi, whenever the angle plus 2 pi, you are going to go back to the same terminal side. Then the trigonometric function is supposed to be same. Now what's sine t? I haven't talked about that yet. Okay, but just for example, when the function is a sine function and the input plus 2 pi, they should be the same in the unit circle. That's for sure because they build the same triangle. Okay, now next I want to spend some time to do my own examples here, because if I don't provide more detailed lectures, you are not able to keep going. Like what's the sine function means, right? Okay, so number one, I want to introduce two trigonometric function. Trigonometric function. Let me change color. What trigonometric function means? So basically, we have six trigonometric function. And right now, in the beginning, I would like to introduce two trigonometric function first. So let me erase all the mark here first. Okay. So first, the trigonometric function I would like to talk about is sine function. Now, what the sine function means? If you have a unit circle when the radius equals to 1, when the radius equals to 1, the y value equals to the sine function when we are talking about the angle is t. And the x value basically is cosine t. So this is y value. This is x value. When we are talking about everything in the first quadrant, it's this simple. Now, how about the radius? If the radius is not equals to 1, what happens? We are going to have more detailed definition because you don't guarantee all the time the radius always equals to 1. So if radius not equal to 1, what happens? Now, I'm going to give you the definition of the sine function and the definition of the cosine function right now when the radius is not 1. So let me go to my other handwriting here. Okay, here. So the real definition for the sine function actually is when you have a right triangle being built, depends on the angle. And the coordinate on the terminal side is xy. Now I don't guarantee the hypotenuse is 1. Hypotenuse means the radius. And the hypotenuse will be x squared plus y squared, square root, because this is x. This is y. And I don't guarantee r is 1. So right now I just say the radius is r, the hypotenuse is 1, is r. Now what the sine means? So sine value no longer be y. Sine, sorry, not the sine, y is sine t. So the sine function, if you input this angle t, t will be the input. to the trigonometric function. You input, and then you have y value over r value. That's the definition. And pretty soon I'm going to explain why we have this type of definition. Because all the definition need to be well defined. Well defined means once you have this definition goes to other situation supposed to be all the time make sense. Okay, so temporary, I will just give you the definition in general. And the cosine t will be x over r. So in the beginning, I said when we have radius equal to 1, when our radius equal to 1, then we have y divided by 1. Okay? Sine t basically is the y value if the radius is 1. If radius is not 1, then we divide by 1. And the cosine value will be x divided by r. If r is 1, then cosine value will be the x coordinate. Now, again, let me go back to the real definition. Now, you may see that the real definition easy for you to memorize is you can see that y, sorry, the triangle disappeared. Okay. The y value happen to be opposite to the angle because angle is our input. And the y value happen to be opposite to our angle. And then r is always hypotenuse. Now, the x value happen to be next to angle t. Next to, we say adjacent. Adjacent means next to t and divide by r. Now, why we have to divide by r? That's the next thing I want to talk about. So, when r is not equal to 1, we divide by r to make it equal to 1. That's what it means. Now, if r is not 1, what happens? So next we go to another lecture here. So see, if you have some angle t here, if we have angle t here, and this angle t, if inside one circle, definitely this circle won't be a unit circle. It's not a unit circle because the radius is not 1. Radius is 5, so this circle is supposed to be very, very big. I cannot draw it. But anyway, any angle will build a triangle. And this, I mean a right triangle. A right triangle, always say that. A right triangle, right? A right triangle. Now, this right triangle, I provide a very special triangle. The opposite side is 3. And the adjacent side, adjacent to the t, is 4. So I say x equals to 4 and the y equals 3. This point will be 4, 3, the coordinate. And the radius is 5. So by our definition, we try to find sine t. So sine t will be opposite divided by radius. 3 will be 3/5. And the cosine t will be adjacent divided by r. Okay, now we just follow the definition and we follow the given. But there's one more thing I want you to double check for me is do you see it's so special? This triangle, they have 3 sides, 3, 4, 5. That's very, very special. Not all the time you have 3 sides, 3, 4, 5 next, the numbers so beautiful next to each other. And you don't see any square root at all. Basically, when you have right triangle, you need to deal with Pythagorean theorem, which is you need to deal with the deal with the Pythagorean theorem all the time. So, in other words, when you have a right triangle, always square root need to happen. And when you see a triangle, all 3 different sides are whole number. You don't see any square root. That's really, really rare. Okay, so this is very special. But anyway, because that's just in the beginning, so I try to find a very, very special triangle to give you as a special example. Now, let me erase all the extra mark. So, let me read. Okay, that's fine. Let me did all the mark here for now. Now, I want you to double check for me. 3 square plus 4 square. No, yeah, 3 square. Square root of 3 square plus 4 square is square root of 25 is 5. So actually, if you really have a right triangle and the radius happen to be 5, that's true. Okay, I say it's not going to happen all the time, but it happened. Now, if I want to make the radius equals to 1, so let me divide by 5, divide by 5, divide by 5. What happened? Then I have a new triangle, a smaller triangle. Okay? Now, when I have radius is equal to 1. Oh, okay. Okay, I cannot see the work here, so let me rewrite. So this is sine beta, right? So sine beta equals to cosine beta equals to. So sine beta will be 3/5 opposite divided by radius. So divide by 1, just the same thing, 3/5. And the cosine beta, by the definition, is adjacent divided by radius. So is 4/5. Do you see? They have same answer here. 3/5, 4/5, same answer. So that's one thing very special. Okay. Now let's take a look here. How about a smaller triangle? If I make the radius half, I make a radius half. So I divide by half, half, half. What happened? I divide by 2, 2, 2, not divide by half. I divide by 2, 2, 2. So divide by 2 means I multiply 2 to the denominator. So sine alpha will be 3 over 10 divided by 1/2. And okay, this disappeared. Cosine alpha will be 4 over 10 divided by 1/2. Now you understand, divided by 1/2 means times 2, so in the end, you have the same answer, 3 over 5 and 4 over 5 here. Now it comes a question here. If sine alpha, use black color, if sine t equals to sine alpha equals to sine beta, do you believe those three angles are equal angle? Angle alpha equal to angle beta equal to angle t. Do you believe so? And actually, yes. So, because right now our school does not provide geometry before trigonometry. So that's why I need to teach the class one very important concept from geometry, which is we call similar triangle. Similar triangles. If you had two triangles similar, what happened? Or you have many triangles are similar triangles, what happened? So in other words, if I divide by 5 for every side, what happened? If I divide by 5, it roughly is 1, 2, 3, 4, right? 1, 2, 3, 4, 5. If I divide this triangle by 5, and then I build a new triangle here. Okay, so let me use some lighter color. So this small triangle with angle T basically is the same triangle where you have angle beta. This beta actually is T. You can just insert this triangle to the tip of the big triangle. And I guarantee this will be 3 over 5. This will be 4 over 5. Guaranteed. And why I can guarantee that? I cannot prove it. I'm not going to prove it because cannot be proved. Cannot be proved. Something cannot be proved, we call it axiom. Axiom. Or we call it something like a property, or most of the math rule supposed to be proved, to be believed. But something, there's still something no one are able to prove it. So this is one of the things. Similar triangle, if you have the same angle, then all the sides form proportion. So if I divide by 5, divide by 5, divide by 5, they are going to keep the same angle. And if they have same angle, if you multiply 5, multiply 5, multiply 5, you build a new triangle with all the sides multiply 5. Then If you multiply 5 on one side, this side will be multiplied by 5. I think I need a bigger space to explain more detail here. Okay, here. Okay, let me draw a big triangle. Let me change the color here. Okay. So, in other words, if you have 3, 4, 5 with whatever the angle t, okay? If you keep the same angle and you divide by 5 for the r, then you are going to have a smaller angle. Let me see if you have a smaller angle here. Okay, say this is 1. Now, how you get the 1? Because you use 5 divided by 5. Now, the similar triangle property guaranteed if you divide by 5 for the hypotenuse, then to become 1. Then I guaranteed when you build a right triangle for this r equal to 1 with the same angle, I guaranteed 3 will be divided by 5 here. 4 will be divided by 5 here. I guaranteed, and without proof it. Okay? Now, how about if I divide by 3 from 5? What happens? If I divide by, let me choose a better color. Okay. If I divide by 3 from 5, for example, here, okay, so here you have 5 over 3. Then this 3 need to be divided by 3. This 4 need to be divided by 3 also. So this length become 4 over 3. This length become 1. This length, when you have 5 divided by 3, then every single side, we say the corresponding side form proportion. The corresponding side form proportion. So for example, if you have 3, 4, 5 for the big triangle, then for the green triangle, let me choose the right color. Okay. If you use the same, if you choose the same angle t, so it means you try to build the same triangle, just bigger size or smaller size, but correspond to the same angle t. So for the big triangle, you have 3, 4, 5, right? Then for the purple triangle, you have 1, 4 over 3, and 5 over 3. Still, if you times 3, 3, 3, you have 3, 4, 5, right? So there's a same proportion. And if you talk about the green triangle, you have 3 over 5, 4 over 5, and 5 over 5, which is 1. If you multiply 5, 5, 5, you are going to go back to 3, 4, 5. So when we are talking about the same angle, and this is the similar triangle property, they can go back and forth. So if we have angle T for angle T, we guarantee that. So if you have angle T, I guarantee this thing will happen. And in other words, if I have 3 triangles form proportion, then I guarantee these 3 triangles have the same angle. Okay, if this angle T, this angle alpha, this angle beta, I guarantee these 3 angles are the same angle T. So this is how we call similar triangles property. Now, I think I better end my video here because it takes too long. Probably you are tired right now. So do a little bit review. We just went through number 2 and the number 3. And the number number 1 and number 2. We just went through number 1 and the number 2, right? And the number 3 we are talking about a function is periodic, means if your input plus certain special number, they will go back to the same function value itself. Yeah, we did talk about number 2 earlier. And then number 4, very easy. We learned that from chapter 1. If a function is odd, then it follows this. And if function is even, then it follows this. You may review. Okay, if you still have questions, we may talk about in the class time. And then I may stop my video for now, and then next video we are going to start from question 5.